Okay, so I have a slightly longer discussion than the previous discussant, but may not as good though. All right, thanks for having me. So that's the paper, and that's me. I considered. All right, the paper tries to report two findings. One is theoretical, that that firms in general, firms with greater investment flexibility, do not in general have lower risk and risk premiums. And the second finding is more empirical, evidence on how firms are different in the cross-section in terms of their investment flexibility. So the conclusion or interpretation in the paper is that irreversibility is unlikely to explain the value premium, and that's the last sentence in the abstract. I believe this is what Dirk was referring to as the controversy part. All right, I interpret the paper as a valuable contribution to the literature in the sense that it provides a careful exposition or clarification of the oftentimes subtle relations among inflexibility, operating leverage, book to market, and risk premiums. Actually, I only have one concern. So my concern is that the interpretation seems a bit too strong. In fact, the results are much more ambiguous in the paper, and I have 2 bullet points here. Actually, just one concern. The theoretical results are more ambiguous than what the interpretation is giving the impression. And then the empirical results are also not exactly waterproof, in the sense that the empirical proxies used to measure inflexibility seems to be a bit noisy, and I'm going to cast my concerns most as questions. Of course, I'll leave the audience to decide. All right, so here's how I organized my discussion. I'm going to first go over and comment on the theoretical relation between inflexibility and risk premium, and then I'll comment on the author's simulation study, simulation computational experiment, and then I'm going to comment on the empirical analysis. All right, the model is extremely parsimonious, extremely simple. You cannot get simpler than this one. So partial equilibrium model, newer classical investment. The pricing kernel follows geometric Brownian motion, constant price of risk, no time variation there. Operating profits, right? So you have revenue, theta is productivity raised to the power 1 minus gamma times capital raised to the power gamma, and then you subtract flow production costs, which is proportional to capital. Okay, so very, very, very standard. The paper models investment inflexibility as capital adjustment costs. There are different moving pieces in the paper, but I'm just going to focus on the key ingredients. So one is when investment is positive, okay, so that's the cost you're going to pay. Delta K is change in capital, that's basically investment, right? PL is purchasing price, PL minus 1. This would be a total PL times delta K is the total cost of positive investment, and then minus 1, that would be your adjustment costs. So when investment is negative, you pay different costs, so that admits costly reversibility. So in particular, if PU is very close to 0, right? So for $1 of capital you sell, you get 10 cents back, and that's 90 cents costs. Okay, so that's the negative investment. So that's the basic setup. Even under this extremely simple setup, and you get some dynamics. So here is a graph, figure 2 of the paper, slightly different from what you saw in the presentation. The vertical axis is risk premium. Horizontal axis is operating leverage, because there's only one state variable in the model, so conditionally everything is 1-to-1 correlated. So when times are good, sales are going to be high. All right, so operating leverage is going to be low, so we're operating in that region. Whereas when times are bad, sales are low, operating leverage is going to be high, so we're operating in this region. So you can decompose firms' risk premium into 3 components, value weighted, of course, assets in place, the expansion option and growth option. And sometimes people in the literature like to evaluate the expansion option and the contraction option and call that growth option. So what we do see here is that in good times, growth option, it's roughly same level of riskiness as assets in place, maybe slightly riskier. Okay. Whereas in bad times, you see a lot more action here. In particular, assets in place are more riskier than growth option. The main reason is that the contraction option is more like insurance contract. It's a put option, pays you money when you decide to downscale, so that helps you control your risk. So that's that. And the figure 3 of the paper shows the effect of the degree of costly reversibility. So the top line is the case with the most severe calibration of most severe degree of costly reversibility. And we can see that, hey, we see some value premium now. High book to market earn higher rates of returns than low book to market firms. And once you start to vary the degree of costly reversibility, things start to get like or either flat or even flip the sign. Okay, so in fact, my memory of how the literature has been developing is that actually we got the growth premium first. The literature got there first. So. Right, papers argue growth option is always riskier than assets in place. So people got together later on and say, hey, we need to reverse that. Otherwise, we don't see the value premium. So that's how costly reversibility or time varying price of risk, Carlson Fisher, J. Marino's operating leverage start to pop up in the literature. So we get there something at the top curve. All right. Taking stock, the model seems to show that disinvestment costs dominate investment costs, or downside costs dominate upside costs in matching the value premium. And the paper acknowledged, yes, that's consistent with prior findings, but the paper is quick to point out is that what is novel, however, is that for firms with even a mild degree of reversibility, the average slope of the line turns negative. And that's, of course, it's the truth. Now, the key question is going to be empirical or quantitative, right? So given that that's what we find in the model, now the important question is going to be, is the degree of irreversibility used in prior studies plausible from an empirical standpoint? And that needs to be further studied. Now, let me move to the simulation study of the paper. So the paper in total, the model in total, despite its being so parsimonious, still has like 9 parameters. All right, so you have 2 production parameters in the production function. Delta is rate of depreciation, and 4 parameters in the adjustment cost technology, and the 3 parameters in the exogenous forcing process. So there are in total 9 parameters. The authors pick 2 parameter values for each, 2 raised to power 9. You have in total 512 sets of parameter values, and then the paper simulates 1,000 years worth of data for each one of the 512 economies. So just want to point out that so this computational design, it's a bit different from the way quantitative theory is typically done. So in there, what people usually do is that we try to take a stand on the empirical standpoint. From an empirical standpoint, we calibrate the model parameters to available evidence as much as possible. When evidence is not available, we calibrate following prior studies. And if we have to use non-traditional parameter values, we try to be careful in carefully documenting what the exactly parameter values are doing to the quantitative results through careful set of comparative statics. So whereas here, we seems to be going after a general pattern that is true under all parameter values. All right, so this is a figure 5 or 6 in the paper. So average risk premium plotted against irreflexibility measure This is like 4 out of 512 economies. So if you just fit the straight line, it seems to be negatively sloped. Okay, and therefore, the paper concludes is that in general, there's no relation between inflexibility and the risk premium. In particular, the paper argues that the primed heterogeneity in the data just happened to plot in a way that is positively sloped. Okay. This is certainly sensible, and I believe it's a valuable, again, valuable contribution to make in the literature, and it's a useful point to make, that the positive relation between inflexibility and the risk premium is conditional in the sense that it does depend on primed values. Okay? On the other hand, the goal of quantitative theory is not to prove theorems that are true under all primed values. We call that mathematical economics. So, so we're operating under the influence of the quantitative theory style, and people say, hey, there's this old GE theorem called anything goes. Sanshine-Montel-Debreu theorem says that under GE you prove the existence, and if you are lucky uniqueness, that's pretty much all you can say. So if we want to take the model to the data and say something about how the empirical puzzles can be understood, then we have to take a stand on functional forms, parameter values. So that's why we need to restrict our hands in that regard. So bottom line is that the goal of quantitative theory is really to quantify key mechanisms under empirically plausible parameter values. What does that mean? It means that if we want to conclude that custody reversibility or irreversibility doesn't really matter for value premium, and we have to show that the prior calibrations are implausible. That's, of course, perfectly possible. All right, finally, let me comment on the empirics. All right, so before I get into my comment, I just first acknowledge that the inflexibility is extremely hard to quantify. It's like pornography. You can probably sense it, but write down a measure, a quantitative measure, and sort firms into that. Based on that measure, is going to be difficult. Okay, so the baseline measure the paper is using is the sum of costs of goods sold and SG&A, okay, divided by sales. So, so that's the inflexibility measure, and my concern is that this flexibility, well, this proxy is not that related to adjustment costs, right? So, or inflexibility that's modeled in the paper. So the first part, cost of goods sold, that's actually, and Robert has been using that as a measure of operating leverage, and that's a little bit of a stretch as well, but because CompuStat is not concerned about the economist's need of measuring fixed costs, so we do the best we can. We say variable costs are close enough. Okay, we understood the weakness and we do what we can, right? But that's an operating leverage measure, right? SG&A, the interpretation is probably even more controversial. It's actually organizational capital investment, or brand capital investment, or intangible capital, and Lev, well-established accounting academic at NYU, has been using this measure for years, and more recently there are more papers in finance popping out as well. All right, to make my point a little bit clearer, so this is the table in the paper that lists different industries with different degrees of inflexibility as measured using the measure they use. So lots of numbers. Just focus on the last two rows. One is tobacco, one is pharmaceutical. So the paper argues is that those industries are most inflexible. On the other hand, we know tobacco is pretty big in advertisement. It's brand capital intensive. Pharmaceuticals, a lot of R&D related business, right? Intangible capital. So my question would be, tobaccos and the pharmaceuticals, are they most inflexible in terms of downward adjustment costs are highest, or are they really intangible capital intensive? All right, okay, so I'm gonna conclude. So Again, I interpret the paper as a valuable contribution to the literature, and in my view, it deserves to be published in a reasonable place. It provides a valuable clarification of the subtle relations among inflexibility, operating leverage, book-to-market risk premium, and the stuff. And I would interpret the key theoretical results with a little bit caution. I do believe that heterogeneity, primary heterogeneity across industries is important direction to go. And I would, because ex-ante measures are just so hard to get our handle on, so I would actually go for structural estimation. You estimate the model industry by industry, estimate adjustment cost parameters, and trying to figure out whether the primary estimates line up in the cross-industry variation of the value premium. And then you can comment on whether prior studies calibration is implausible or not. Okay, that's all I have.